Gravitational potential energy to kinetic energy transfer calculations by KayScience.com. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. This person throws a 1 kilogram ball into the air. So they throw a 1 kilogram ball into the air. So if we're going to try and calculate the gravitational potential energy stored in the ball, we have to know the height it is away from the ground. And the ball is 5 meters above the ground. So to calculate the gravitational potential energy stored in this 1 kilogram ball 5 meters above the ground, we need to recall the equation gravitational potential energy equals mass times height times gravitational field strength. So we don't need to rearrange the equation because we're working out gravitational potential energy stored in the ball. So you then substitute in the numbers 1 kilogram times 5 meters times 9.8 newtons per kilogram. So the energy stored in the gravitational potential energy store of the ball is 49 joules. There is 49 joules stored in the gravitational potential energy store of the ball. It's question time. Attempt these questions to check your understanding. So at the maximum height the ball reaches, which is 5 meters, it's going to be stationary. There is 49 joules stored in the gravitational potential energy store of the ball, 5 meters above the ground. So there'll be zero energy in the kinetic energy store of the ball. Let's now imagine that the ball falls with zero air resistance acting on the ball. So when something falls, energy from its gravitational potential energy store is transferred to its kinetic energy store. So for a falling ball, when there's no air resistance, you can use the principle of conservation of energy. So over the course of the 5 meters the ball falls, the energy from its gravitational potential energy store, that's 49 joules, will be completely transferred into the kinetic energy store of the ball as it falls. This is if there's no air resistance. So on the way back down, at 2.5 meters above the ground, the ball will have energy stored in its gravitational potential energy store. So how many joules of energy are going to be stored in its gravitational potential energy store? To recall the equation, gravitational potential energy equals mass times height times gravitational field strength. Substitute the numbers, 1 kilogram times 2.5 meters times 9.8 newtons per kilogram. That gives you 24.5 joules stored in its gravitational potential energy store. 24.5 joules stored in its gravitational potential energy store. Where did the energy go? Well, the ball is moving. It has kinetic energy. So that energy will be transferred to the kinetic energy store of the ball. So because there was 49 joules of energy in its gravitational potential energy store at its maximum height of 5 meters, on its way down, there'll be 24.5 joules stored in the kinetic energy store of the ball. It's question time. Attempt these questions to check your understanding. So the ball is now 1 millimeter above the ground. Let's now calculate the gravitational potential energy stored in the ball. 1 kilogram times not 1 millimeter, but in meters it's 0.001 meter times 9.8 newtons per kilogram. So the gravitational potential energy stored in the 1 kilogram ball is 0.0098 joules. So 1 millimeter above the ground, the ball is going to have 1,000th of a joule stored in its gravitational potential energy store. That energy has been transferred to the kinetic energy store of the ball. So the ball now has 48.99 joules of energy in its kinetic energy store 1 millimeter above the ground. So if you were to round up to two significant figures, the ball has 49 joules of energy stored in its kinetic energy store 1 millimeter above the ground. So over the course of the 5 meters the ball falls, the energy from its gravitational potential energy store, that's 49 joules, will be completely transferred into the kinetic energy store of the ball as it hits the ground. This is if there's no air resistance. We can use the kinetic energy stored in the ball to work out the speed of the ball as it hits the ground. So we want to calculate the speed of the ball, v. So recall the equation, kinetic energy equals half times mass times speed squared. And you can also recall it like this. You cover v squared and you're left with v squared equals kinetic energy divided by 0.5 times mass. So you then substitute the numbers. Kinetic energy is 49 divided by 0.5 times 1 kilogram. V squared equals 98. V squared is not v. So to calculate the speed of the object, you must square root your v squared answer. So you square root 98. So v equals 9.90 meters per second. So the speed of the ball just before it hits the ground is 9.90 meters per second. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.